Good day. My name is Kealey Ruhaya, and I will be taking you through my biometrics project. The topic of my project is to test the effectiveness of the environment on a face anti-spoofing system. So in this presentation, I'll be taking you through these four sections: the methods that I had to use to complete this task, the similar work, and the experiment setup, and lastly, the results. The aim of the project is to test the impact that environmental changes have on the accuracy. So the types of environmental changes that I have tried to change are the lighting and the background. So with the two different pipelines, the differences would be the lighting and the background control of the data sets. So the tasks that we'd have to complete to complete this project would be creating data sets. The reason for creating data sets, we would be able to control the environment, like the lighting and the background. So then we'd move on to pre-processing the images. Those images that are collected we'd have to make sure there's no blurriness in any of the images, and we'll make sure that the selection of the face is just the face and not the background. So we'd move on to model training. Using the data sets and their labels would train the model, and all of it was coded in Python. The similar work, other researchers have tested the effect that lighting has on their system. In these two papers, for example, they tested it for face detection and expression recognition. For the experiment setup, there are four phases: dataset collection, pre-processing, labeling, and then model training. So I'll be taking you through these sections. The dataset collection, the data that's collected is in the form of images, either a real image or a fake image. For the real images, I used my face or some of my friends' faces. And for the fake images, used a screen pointed at the camera or a printed out piece of paper of someone's face pointed at the camera. The dataset is about 14,000 images, and the difference between the two pipelines were the way that the dataset was taken. So the first dataset was taken in a way that's optimal, has the optimal lighting and background, and pipeline 2's more realistic conditions. So for the real face, here's some examples of what it looked like to collect the data for the real face. As you can see, there's some that are just my face, some have glasses and hats on for the people that would be wearing that, and some other faces that are part of the data set. For the fake faces, you can see that the first picture is a picture of myself printed out, pointed at the camera, and the second face is a picture of someone on the phone. And the last one is that same person printed out on a piece of paper. So for the dataset pre-processing, the two tasks that we did for pre-processing was to reduce the blur, making sure that all the data in the datasets are not blurry images, they're all clear images, and the background removal, just making sure that the selection is their face and not their face and the background. So for the labeling of the dataset, for each image that's collected or created, there's a label that's created and stored in the form of a text file. Inside the text file, the label file contains a classification, which is the real or fake, whether it's a real face or a fake face, and the coordinates of where the face is. So then we move on to training the model. The model is a YOLO V8 model. The model was trained on 14,217 images. Training the model, we used 9,953 images. For validation, we used 2,843 images. And for Testing, we use 1,421 images. The complete model took 15 hours to train. So now I will take you through a live demo of the system. Okay, so as you can see, the system is um, recognizing my face as a real face. And if I get a picture of myself, if I print it out, um, it will, there we go, it will recognize it as a fake face. If I use a different face, it can also recognize that as a fake face. So for the results, in the first pipeline, we found that the accuracy was 86%, which is high as expected because the dataset and training was in the optimal conditions like the lighting and the background. In the pipeline 2, the accuracy was 66% on fake faces, but the model did not was not able to detect any real faces. So yes, there was a 20% decrease in the accuracy on fake faces between the two pipelines. Here's a confusion matrix to show more accuracy on the true positives and the true negatives. Um, so the challenges that I faced in this project were the processing power of the laptop that I was using. It took very long to train the models, and because of the processing power of my laptop, I was not able to train the models on a higher epochs because that would take too long, which would have had more accurate results. So one of the conclusions of this experiment is that the lighting and background is very important for a model to output high accuracy in face detection, face recognition, as we've seen in the first pipeline, how much more accurate it is at detecting a face as a real face or a fake face. The pipeline's results that we got are as expected, and what wasn't expected, the results that we got that we didn't expect were the pipeline 2 to have to not be able to detect any real faces. Thank you.